Hello, and today we're gonna be doing some motion graphics based on the exploded view node over here, which is a subnet, as you can see over here. And the idea came from, well, I was playing with the Voronoi noise, and I actually played with the scale over here. I realized you can actually increase the scale of this, so I kind of thought of a way to animate this stuff. So let's go ahead and start digging into how we can actually hack the exploded view and make something out of it which is actually animatable. Let's get this. Okay, so we're gonna be animating the for each node today, and the main idea is, it's from this particular guy, the exploded view, which if you go ahead and extract the contents, what you're gonna actually see is a group of nodes which actually do the job over here, which you have a connectivity sub with primitive type of primitive, and creates an attribute, and it passes that attribute onto the for each node over here. Then over here you have a for each group, a for each from the user attribute level, and basically the whole procedure goes down and gets outputted as that. So we're gonna go ahead and do the same thing, only okay, so I got my new network over here. We're gonna go ahead and drop in a font over here, and go look at the font. Now my particular font has a preset of the op name, which actually just types in whatever name you have over here. So if you whatever you type over here is actually what you get on the top over there. So yo, YouTube. Ha. Anyway, you get the drift. So this is what we're gonna be using. I'm gonna type something different though. Let's use something like that. So we're gonna be using a for each node to do the whole thing. So we're gonna be doing a for each, and we're gonna go ahead and dive inside it. And pretty much over here is actually what we're gonna, okay, for one, I need to actually set this up to be a for each primitive. So actually that way, right now we got 13 primitives, so we're gonna work on the first primitive, and the animation is gonna get replicated onto the top level for all the other primitives, right? So we got the single letter over here, and now pretty much what you can actually do is actually use this as the basis of the prototype for all the other animations. So we're gonna go ahead and drop in a verb sub over here that we're gonna calculate some math inside it, pretty much. And I failed high school math, believe this or not. So I don't even know how I use Houdini, but I do. So the idea here is to create the font, the letter over here, to fly out or fly in, and have it smooth, smooth animation in, easy in, ease out, I think they call it, something like that. And so it has to have a second point to go to. Now if I actually go back up and look at the exploded view over here, which I'm gonna go ahead and drop another one. The main idea over here is that the exploded view can just has a particular target point which it actually goes to. In this particular case, I'm not sure how the whole thing works, but it actually just goes straight up, right? Like the normals pretty much pointed up to where it actually needs to go. In this particular case, the sphere, just being the sphere that it is, it just points everything out. So I'm gonna go ahead and go back inside my other node, and we're gonna use the same concept. So I'm gonna go, you can actually do this on the top scene level, then plug the info into this, but I'm gonna just go ahead and do it all inside over here. So I'm gonna go ahead and drop in a sphere over here, and now this could be any particular shape. It doesn't have to be a sphere. I'm gonna just choose to use a sphere right now, and this is a polygon mesh. I'm gonna go ahead and make the radius big, not that big, but just big enough. Then we're gonna scatter some points on it, right? And we don't need 5,000 points. We just need the number of points that are actually on this particular primitive right here. So you might want to create a reference node for this right here, but I'm gonna just go ahead and use that directly, being that I'm not making an asset as of right now, a digital asset on it, anything. So we're gonna go ahead and use the number of primitives on that particular node. So we're gonna go ahead and go up 2 times. So go up, then we can use that node over there, and it's gonna give us the number of primitives, and in this particular case it's 13, and over here if you actually look, you have 13 primitives, and that's actually what you want. So you got 13 points as of right now. If I go ahead and turn on my point display and make sure the points are visible on the viewport, so you got 13 points all over the place, which is nice and dandy, but we actually need to go ahead and delete all the points, because we just have one primitive as of right now. So hold up, what did it say? 13. So on this particular we got, hold up, why is it saying 13 for each primitive point? Let's refresh this. Okay, there we go. I don't know why it was all lumped up, but okay, so we got 13 points right now, and we got one primitive over here. So actually need to go ahead and delete all the points except one. So we can go ahead and use a delete sub over here, and we're deleting the points in this particular case. This particular point is actually where we're going to be deleting. So the delete sub can choose points as the entity type, and we can delete by expression. And now you can actually just use the $pt, which is the point, which is equal to the stamp value for the loop value for that particular for the for each expression, for the for each node in that particular case, in this particular case. So we can just use the same node in this particular case, and the for value to being the value for the stamping, and a 0 for the default value just in case it doesn't find anything. So in this particular, we should have just we have 12 points. We actually want to delete non-selected, so now we actually have just one single point. Now what we want to do with that one single point, for one, we actually need normal position data from this, so because it doesn't have any normals or anything like that. So you can add a point, can add a point sub and add normals, and pretty much what that's gonna do is give these babies something to look at. So scale normal, now you got them boys over there, and now if you scatter, everything gets pretty much it's a downstream, so everything gets the same data passed down. And I'm not sure about this, whether you want to do this, but if you actually drop in a reverse, I don't think you want to do that. Actually, you want to scale the normals in a negative value, but I think you want to point them in. I'm not sure, but we'll play around with that, see what happens. Then what else can we do next? We got the normal data. We actually want to pipe it in onto the, you can pipe it into any of the other three. I'm gonna just pipe it into the second one, which will be index 1. So we're gonna go ahead and dive inside the VOPs up, and let's boogie with some trigonometric functions. Cheer. Okay, so we're gonna be using VOPs to create the whole thing, and being that this is plugged in, we're actually gonna be getting the information from this, plug it into this as the output. So if we go ahead and dive inside our VOPs up over here, we don't even need the globals. We can just go ahead and import the normal positions from the first index, and the normal is actually what we want, so we're gonna type in a capital N, and now you're actually getting the normal data straight from there. So if you actually plug this into here, you get the normals actually pointing the same direction as the other normal over here, which you actually visualize this, you actually see points down the same exact way. So we're actually not trying to do that. What we're actually trying to do is get the angle in between both of those, or get the angle based off of the normal, and we're actually going to be using trigonometric functions for that. So we're going to go ahead and drop in a trigonometric function, and what we actually want to use is the arc cosine. So if I pull up my text port, and we get the x help for the arc cos, you actually see that it returns an angle pretty much, or the arc cosine of the argument, of which it's a float number in this particular case. So we are getting angles in return. So the involves actually how you'd actually have to do this is actually, for one, break down the vector, the normal vector, into the three main components, and then get the length of the vector, which if you actually go back to the thing over here and type in the help for the length, you'll be given, there's also another method of doing that, which is the square root of the x squared plus the y squared plus the z squared. Then we need to get the length for that, for one. So we get the length of the normal, and then now we can actually just go ahead and divide every single component by the length. So in this particular case, we're going to divide the x, I think that's the first one, and plug that output onto the trigonometric function over here, And now you can actually just go ahead and plug that in as a float to vector, and plug that in into, you can plug it into normal, or you can go ahead and add a new attribute and just create a new name for it, like rotation or something like that, then use that as the attribute. In my case, you can just plug it into normal. You don't really need the normal data after this. Now the only thing over here, if you actually did this whole thing in the point top level, Houdini will actually go ahead and convert everything as is needed, because everything as of right now is being calculated in radians. So actually need to go ahead and convert this from radians into degrees. So actually need to go ahead and convert radians to degrees. And now what you actually have is, if you actually go ahead and visualize this add attribute which you have over here on the VobSop. Oops, I meant to say spreadsheet. What we have is an angle of -23. I don't know where the rest comes from. Pretty much that's the one angle that we actually need, and everything else just gets, it's gonna get calculated as is necessary. So I'm gonna go ahead and turn off this, and pretty much now we can actually have our normal our letter over here to actually go to that particular node. All we need to do is actually go ahead and, well, for one, we actually need to go ahead and do this whole iteration again for the 3 components over here. So instead of actually having to create all these nodes again, we can actually just go ahead and collapse this. Actually, I'm gonna just leave this outside, being that we need it as so. We can actually go ahead and collapse this 3 into a subnet, so that way we can just pipe in the others directly. So we can just have this, and we can copy paste 2 times. All right. And I'm going to turn off, by pressing E you can turn off the drop on wire. So you can go ahead and now you can just need to go ahead and plug in the X and the Y, so the Y over here and the Z over here. So we're getting the same calculation done all over. So if you dive inside the node over here, it has all the stuff being done the same way as the previous one, only a little bit cleaner, being that you don't have to deal with the stuff too much. So this is the Y, obviously, so we're gonna plug this in over here and plug this in over here. So pretty much right now we actually have the rotation angle. So actually I did copy this 2 times, my bad. So right now we actually have an output of rotation. So we actually go ahead to the for each node, actually look at the angles that we have, and we actually have those kind of values. You see that all the others are the same, so if it's being animated it cannot be all the same. So this is actually what we are looking for, the very top number over here, which is the 0, which is the calculation from the normal. And pretty much we can just go ahead and do a mixing of the previous position. Actually, I guess I did lie. I need to go ahead and drop in my globals and get the, I'm gonna just output as a single and get the point position. And what I actually want to do is, well, you got 2 options. You can use a color mix, and I'm gonna let you know off the bat that the color mix has a kink to it. So it has like a little you can tell where it actually switches up. So you might want to try it, but I'm gonna go ahead and use a mix. The mix really does a really smooth transition in between both of those. So you might want to go ahead and just, try both of them and see, what works for you and what doesn't. So in my particular case, well, mix is what's gonna work for me, and we're gonna be mixing the original point positions, the original value. So this is the where the letter is actually sitting when it begins the whole animation, and this is where actually it's gonna be headed after it finishes the whole animation, if that kind of makes sense. And for the bias, we're just gonna promote the parameter, and this we can just plug it in into the normal position. And as I said, this is completely optional. You can just plug it in into this, and you can just reference this particular attribute instead of the N attribute, being that the N attribute is actually what the normal data is. But it's the same way, it's just a way of storing data. Matter of fact, you can even store it over here. It don't matter, because right now if you go back up on the spreadsheet, you got a color attribute with the same values. You can pretty much store it anywhere you want to, provided you know where the data is, you're good. So let's go ahead and drop in the next nodes so we can actually go ahead and finalize the animation. Okay, so we're gonna go ahead and change the position of the letter over here to wherever the normal the position of the second point is, or in this particular case this particular point. Now this is going to be random for every single point, being that we're scattering the points. So we're actually going to go ahead and use a transform for that, and we're going to be using the point expression. So on the translate, we can actually just go ahead and type in the position of the delete. So we're going to type in point, and we're going to be getting the delete node over here, and it has only one single point, so you can just type in a 0, and the point position is actually what you want to get, so it's a capital P, and the X value, so a 0 for the index, and enter. So now you can just go ahead and copy this, tab paste it, and change the last value to a 2 for that one, and a 1 for the second one. So you got a 0, 1, 2 on the indexes for all the point nodes. Now if you actually go back up, what you got is, well, you got the different colors, being that we actually have the color plugged in over here. I'm going to go ahead and plug this in into normal, so you just have a single base color. And if I go back up on the top view, you got all the letters. Well, for one, there's still, I'm gonna go ahead and drop in an extrude over here, and if you actually look, all of them are just facing the same direction. So go ahead and initialize this so they ain't too big, and you still got normal data, so that's why they're all black as of right now. So we're just gonna go ahead and, for one, kind of try shift the positions from one side to the other. So right now it's in between, being that if you do remember, we had an animation bias over here. So if you actually change the animation bias, if I take it all the way down, close to down, if you go back up, and well, why did it not change? Oh, it's not plugged in into position. We actually need to go ahead and plug that in over here. So what I'm gonna go ahead and do is actually make an parameter on top over here, and actually I'm gonna go ahead and drop in a folder, so that way we actually kind of have a neat thing to go with. And I'm gonna name the folder, and we're gonna name the parameter over here position, and a name position for the label. Okay, if I can actually type. And now if I accept this, and now we got this. So I'm gonna go ahead and copy this, and we're gonna use this as the bias on the VOPs up over here. So I'm gonna just go ahead and paste relative references. And now if I actually well, on the transform, well, you really can't do nothing. Like, you actually need to go ahead and paste the values on the transform over here too. So I'm gonna go ahead and paste the relative references over here, copy this, and then delete that. Then I'm gonna go ahead and put a multiplication and paste the link as it is. So I'm gonna copy this, tab, and paste it, tab, and paste it. Now what you have is an interpolation in between the original and the new one. So if you actually look at this, now you actually have all the letters on the base at 0, and if you actually go all the way down, you actually get this shift from one position to the next one. So if you actually look at the extruded version, everything is still on one. It doesn't like change direction or angles, so everything's just flat till now. So it kind of works, but we still need to plug in the rotation value. So we can actually just go ahead and do that over here, and that's going to be done on the rotate. Now if you do remember, the values lie in the normal in this particular case, or in whatever value you actually plugged in the this right here, the values for the vectors. So let's go ahead and type in the rotation values, and that's going to be done obviously on the transform over here. So we're going to be using the point expression one more time, and this time it's going to be referencing the VOPSOP, being that the VOPSOP is actually what holds the data, and we're going to be using the fast point, and we're going to be using normal, being that that's actually where I have my particular attributes stored in, and 0, and close that. Okay, now this particular value should be in this particular, it's a small value, we won't see nothing different on the viewport, but we're just gonna go ahead and copy this, tab paste it, and change this to a 2, and change this to a 1. Now the values over here are not too drastic, but I think we got a little bit of an angle over there going. So if we go back up over here, we're actually gonna go ahead and animate this, and if you actually look, you got this all around. Okay, we need to go ahead and delete that attribute. which is the normal attribute. You've got grade attribute, and you can delete the attribute which is a point attribute, which is a normal attribute. And now if I actually visualize this and go back up, what we got is different rotation values for all the points, and now everything is animated as is supposed to be. Now you only have one variation in, there's only one kind of animation to play with as of right now, being that the scatter just scatters the points all in one single position, but the rotation is actually working, so that's good. So if you actually want to create a wow, that deep, yeah, something like that. So if you want to create different values, so you can actually frame the camera somewhere over here. That's cool. Where is that D going? Let me try to frame this real quick. Oh my goodness, I lost it. Anyway, you get the drift. So pretty much everything is just gonna, you can just animate it however you feel like. So what we actually need to go ahead and do is well, change the scatter for the seed value over here. For the seed, we need to change this random seed over here to something different. So in this particular case, we can actually go ahead and on the for each, we can actually go ahead and add it and add a scatter on the same thing. So we're gonna call it seed, and seed obviously, and accept. Now this goes in from a 0 to 10 value, which is pretty big. So I might just go ahead and copy this, and I'm gonna go ahead and dive inside this and plug this in onto the scatter, which is this space relative references. And now that's gonna give us a value of 1 2 3 4 blah blah blah. No, actually my bad, that gives us a value of 0.1 1.61, which is not really an integer, so we actually need to go ahead and change that over here into a seal value. And now what you're gonna get is a value of 3. That means on the top level we have a value of 2 some point something. Now the way that works, you'd have to actually look that up on the over here. You can use seal, or you can use floor. Floor is just gonna give you a value of 2 instead of 3. So it just depends. You have to play with all these values and see what actually works for you. And then after that, now you can actually just animate the seed for this, and now you have different positions for the whole thing. And now if you actually animate the position seed, you can just go ahead and do the thing as is. Now probably that's not the animation that you want, so in this particular case I would suggest taking the sphere, which is over here on the, now I did this on the top on the for each node. You can actually do this on the top level and just plug in the delete, plug everything that gets if you input it over here, just plug it into the delete over here. But the sphere over here, let's say you want to change the whole thing to where the camera is, so I'm gonna just assume this is where the camera is, and I'm gonna go ahead and reduce the radius to something smaller. And we can actually just go ahead now and position our camera over here to somewhere where we actually think the animation should be headed. And now you actually see this, everything comes straight up at the camera pretty much. And it's just, the ideas are pretty much endless. You can actually just play with this all day long. You can actually have this is a sphere with the point. You can actually have a clip, so you can have, let's say if you actually look at this, well my bad, this is the clip over here, but now you can actually transform the spheres to have a big shape. I mean pretty much the ideas are endless. I can't go through all the ideas as of right now, and I really don't have the ideas listed anyway, so you'd have to actually kind of play with the stuff and see what works and what doesn't. But as far as for the animation goes, now we actually got the animation just pointing to where we got the stuff. So pretty much everything is done as far as for the animation. Now you can just animate your stuff, and the rotations are working, everything is nice, and pretty much I am done with this motion graphics lesson. And you can play with the seed, get something different, and bam. So lesson is done. Now I'm gonna go ahead and animate my title, and everything being procedural, everything being procedural. I'm gonna go ahead and animate my little thingy and say voila, see you on the next one. out.